Hello everyone. Welcome to today's online class from 591lab.com. Today we will be discussing sample questions of Aruba Certified Professional Campus Access Exam. In this session today, you will understand few concepts related to Aruba wired and wireless solutions. Before I move on, let me introduce 591lab.com. 591lab.com is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we will be covering few topics such as wireless LAN, switching, routing and security from Aruba Certified Professional Campus Access Exam objectives. Let me briefly go through each one of them. Under wireless LAN, topics related to wireless functions and how to build configuration based on customer requirement are included. Then switching includes the implementation of layer 2 and layer 3 technologies and how to validate them. Routing covers the implementation of routing topologies and functions. The knowledge related to security standards, concepts, and Wi-Fi authentication methods are covered under security. Okay, let's look at the sample question under wireless LAN. You are building a configuration in Central that will be used for a standardized network design for small sites for your company. You want to use GUI configuration for gateways and APs while using template configuration for switches. You need to align with Aruba best practices. Which set of actions will satisfy these requirements? Question says that Aruba Central Cloud Management Platform has to be used to configure the small sites of a company, and APs and gateways require GUI based configuration, and switches need template based configuration. This involves creation of groups in Aruba Central. So main purpose of creating groups is to simplify the configuration. Simply the devices that need similar configurations should fall into same group. Let me show you how these groups are configured via Aruba Central dashboard. First, we will create groups. So we'll go to the organization. There'll be one group already created by default. It is called default group. So whenever you provision new devices, it will fall under default group. So I have one IAP here. So it is already under default group. So let me create new groups as per our requirement. So we have requirement of APs, switches and gateways. So APs and gateways need GUI based configuration. Switch needs template based configuration. So first I'll create a group for APs and gateways. AP underscore GW. I'll put a name like this. So it will include access points and gateways because both of them need GUI based configuration. So I will not enable this template option. So I'll keep it disabled and I'll proceed and I create this group. So it asks whether you need Aruba OS 10 or 8. So I'll keep it as Aruba OS 10 and the campus and branch scenario. And I'll keep the gateways as for branch. Okay. And I'll add this group. So then you can see AP underscore GW, that group is added. So I'll add another group for switches, template based group. So I'll put SW as the name. It will include only switches. So it is a template based group. So I have to enable these templates. So it will include both AOS CX and AOS S switches. Okay, I'll add this. So now you can see both groups, APs and gateways and the switch. There's a TG keyword come in front of SW automatically to show that it is a template based group. So now no device assigned these groups. So I have to move this AP to our desired group. You can see this AP. So I'll click this AP and I'll move this AP to the APGW group. I click move and it is asking the destination group. So I'll select APGW because I want to move to this group. So I'll move. Then you can see under APGW group, there's one device, that is this AP. So this is how you assign devices to groups. So if you have a switch, you can assign to the SW group. Now let's look at the sites. Site is the physical location of these devices. So I have two sites created just for this illustration. So site 1 and site 2. These are, so we have to put the address of the real location. Then I have this AP. So I can drag and drop to the correct location. I just drag this AP to site 1. So it is assigning, I am just assigning the devices to the appropriate physical site. So now you can see for the site 1 there is one device. For site 2 as of now there is no device here. So if you have more devices you can assign. So this is how you assign devices to the sites. Now you have seen how the groups are created and how the devices are assigned to sites. Let's look at the answers one by one. Option A. Create one group in central for switches and a second group for APs and gateways. Create a unique site for each location and assign devices to the appropriate site. Yeah, that's what we did just now. So option A looks correct, but we'll go through the other options as well. Option B. Create a single group in central. Create a unique site for each location and assign devices to the appropriate site. But single group cannot support both GUI based and template based configuration. So this is wrong. Option C. Create one group in central for switches, a second group for APs, and a third group for gateways. Create a unique site for each location and assign devices to the appropriate site. Since APs and gateways use GUI based configuration method and all small sites use similar configurations, it is possible to group them in single GUI based group. No need to have a separate two groups for APs and gateways. So this is not correct. Option D. Create a single group in central, create a unique site for each type of device and assign devices to appropriate site. It says single group, so it's not wrong. It's wrong. This is not correct. Single group cannot support both GUI and template based configuration. Therefore, the correct answer is option A. Okay, take a look at the next question under wireless LAN. What steps are part of the key management workflow when a wireless device is roaming from AP1 to AP2? We have to select two answers. Need to understand the key management workflow when a client roams between APs using 802.11r fast roaming the standard. So let's look at this diagram. Here a Wi-Fi client roams from AP1 to AP2. As you can see, client initially connects to AP1 and authenticate in the step 1. After the authentication, the information such as pairwise master key R0, that is PMK level 1 keys, we call it PMK R0. So those keys, VLAN ID, role, are cached by AP1 and send them to key management service. Key management service runs in the control plane. In case of controller based, it will run in the controllers. Otherwise, in case of instant AP scenario, control plane resides in each and every AP. So key management service will run on the AP itself. And then air match service provides the list of neighbor APs of AP1 to key management service. So key management service will receive the list of AP1's neighbors. Then key management service will generate PMK R1 keys. In other words, these are PMK level 2 keys, and send R1 keys, VLAN and role details to AP1's neighbors. So in this case, it is AP2. Hope these steps in key management workflow are clear. So we'll go through answers. Option A. The key management service receives a list of all AP1's neighbors from AirMatch. We'll check the diagram. The key management service receives a list of all AP1's neighbors from AirMatch. I think it is correct. Let's double check with the diagram. Yes, that is step number 3. Yes, it will receive the neighbor list of AP1 from AirMatch. Yes, it looks correct. So option A is correct. Option B, a client associates and authenticates with the AP2 after roaming from AP1. A client associates and authenticates with AP2 after roaming from AP1. No authentication after roaming to AP2. That is the whole idea of 802.11r fast roaming. So there's no authentication after roaming. So this is wrong. Option B is wrong. Option C, the key management service receives from AirMatch a list of all AP2's neighbors. No, AirMatch will provide AP1's neighbors, not the AP2's neighbors. So this is wrong. Option D, AP1 will cache the client's information and send it to the key management service. Let's check in the diagram. Yes, step number 2. AP1 will cache and send this information to key management service. So option D is correct. Option E, the key management service then generates R1 keys for AP2's neighbors. No, it will generate R1 keys for AP1's neighbors. So this is not correct. So the correct answers are A and D. Okay, we'll move on to the next question under switching. Your customer currently has two 5406 modular switches with MSTP configured as their core switches. You are proposing a new solution. What would you explain regarding the Aruba CX VSX pair, switch pair, when the new VLAN IDs need to be created? Okay. There's a VSX pair. It is about the new VLAN creation and how they are synced to the secondary switch. So we have to know exactly what are the parameters and information that are possible to sync using VSX sync mechanism. Let me show you the part of configuration guide to confirm this. So in the under VSX sync command, so these are the areas where you can sync the configuration using VSX sync. So these information can be synchronized. So VLAN context is one of them. So we can see the context here. Yeah. So config dash VLAN. So this is the VLAN context. So when we create the VLANs in the primary switch, so we can use VSX sync command. So then the secondary switch will get those VLAN IDs synchronized. So these are some examples to show this. So even in the example you can see. So we'll create VLAN, then under VLAN context we can use VSX sync. So this is how you enable VSX synchronization for this VLAN context to the secondary peer. So hope this is clear now. Okay, let's check the answers. Option A, use VSX sync command while creating new VLAN IDs. This is correct as per the configuration guide I have shown you, because VSX sync command is available under VLAN context. Option B, keep alive settings need VSX sync configuration to sync new VLAN IDs. Keep alive configuration does not include VSX sync configurations. This is wrong. Option C, VSX users separate control planes and VLAN IDs are always created on individual nodes. In VSX, control planes are separate, but VLAN creation is not always on individual basis because it can be synced. So this is not correct. Option D, new VLAN IDs are automatically synced in VSX. VLAN IDs are not automatically synced. VSX sync command has to be there under VLAN context. So this is wrong. Correct answer is A, option A. Let's look at the next question under switching. With core 1 configuration of spanning tree instance 1 priority 0, what needs to be configured to enable root for VLAN 10 while VLAN 20 remains root on core 2? Okay, so we have to focus on VLAN 10 and core 1. This is regarding multiple spanning tree protocol, that is the default STP mode for AOSCX switches. Switch with lowest priority is selected as root. Here in this case, question asks to what to configure to make core 1 as root for VLAN 1. So it says spanning tree instance VLAN, spanning tree instance 1 is priority 0. So it's already configured. Spanning tree instance 1 is created with priority 0. So this is the lowest priority for instance 1 in core 1. So here, so they are asking now for the VLAN 10. VLAN 10, core 1 should be the root for VLAN 10. For VLAN 20, core 2 should remain as root. So whatever the VLANs map to instance 1 should make core 1 as root for that particular VLAN, because instance 1 is already having the lowest priority. So it's a matter of mapping VLAN 10 to instance 1. So we'll look at the answers. Option A, spanning tree priority 0 VLAN 10. There's no such command to associate the VLAN ID. So it's not correct. Option B, spanning tree instance 1 VLAN 10. This is how to map VLAN 10 to instance 1. It looks correct. Option C, there's no such command with root and priority keywords. This is wrong. Option D, spanning tree VLAN 10. This command is used in rapid per VLAN spanning tree configuration, but here it is MSTP. So this is not correct. So the correct answer is option B. Next question is from routing. Your Aruba CX6300 VSF stack has OSPF adjacency over SVI 10 with lag 1 to a neighboring device. The following configuration was created on the switch. What needs to be done to advertise the newly created networks using OSPF without forming new adjacencies? Okay, let's visualize this setup. So you have there's a VSF stack. There are two 6300 switches stacked using VSF technology. So this is VSF. Then the switch stack is connected to another layer 3 device, either layer 3 switch or router using lag. Okay, this is a link aggregation group. This is a lag, and this lag is connected via switch virtual interface 10, VLAN 10. So there will be a one IP here in VLAN 10, and this is the switch stack. This is the virtual switch stack. So there will be another IP in this switch stack, and there's a OSPF adjacency between these two IPs. So both of these IPs belong to VLAN 10. So OSPF adjacency is established. So OSPF is working over VLAN 10. So now there are new VLANs created. VLAN 20, 30 and 40. So these new VLANs are created, and the relevant subnets, I mean SVIs are created, and there are new subnets to be advertised via OSPF. But OSPF adjacencies should not happen through these newly created SVIs for VLAN 20, 30 and 40. So OSPF adjacencies should not be there. Only VLAN 10 should have OSPF adjacencies. So we have to, so OSPF adjacency, if we want to avoid OSPF adjacency, those interfaces should be configured as passive interfaces for OSPF. So the now the requirement, as per the question, requirement is to advertise the newly created subnets of VLAN 20, 30, 40 into OSPF, but it should not form OSPF adjacencies through those VLAN interfaces. So if need to avoid OSPF packets going over certain interface, they have to be configured as passive interfaces for OSPF. Okay, so then we'll go through the answers. Option A, interface VLAN 20, 30, 40, and under that interface VLAN configuration mode, IP OSPF passive is configured. This shows that VLAN interfaces of VLAN 20, 20, 30 are selected and then made all of them OSPF passive interfaces. So commands are correct. So this looks correct. Option B, route OSPF1 area 0 and redistribute local. This shows redistributing local subnets, but there's no such local option in redistributed command. Redistribute connected and local loopback options are available, but not local. So this is wrong. Option C, VLAN 20, 30, 40, and under VLAN context, there's no OSPF passive. So there's no such command OSPF passive under VLAN context. So this is wrong. Option D, there's no such command like passive interface VLAN 20, 30, 40. Passive interface default is available under route OSPF, but given command is wrong. So option D is wrong. The correct answer is option A. So we have reached the final question under security. In AOS 10, which session-based ACL below will only allow ping from any wired station to wireless clients, but will not allow ping from wireless clients to wired stations? The wired host ingress traffic arrives on a trusted port. Since question says it is AOS 10, this session ACL must be related to wireless control plane, either gateway or AP when enforcing firewall rules. Let's understand the format of the session ACL. To define the session ACL, the command IP access list session, then the access list name is used. After that, rules are defined. Source of the traffic, then destination, and the service, what are the protocols or ports, then the action, maybe permit, deny, that kind of actions. Extended actions are the more actions apart from the permit, deny, maybe, for example, logging certain entries, logging certain hits, so logs. So similarly, you can define multiple rules. There's an implicit deny all at the end of the ACL rules. Rules are evaluated from top to bottom. So once a rule is matched, it won't do further evaluation. So more specific rules should be listed first. We'll check the answers. Option A. So in option A, IP access list session ping from wired. So under rules, user any SVC ICMP deny. So here user is the wireless user, that is the source. So destination is any and service is ICMP and it is denied. So ICMP from wireless users are denied. So second rule is allowing ICMP from any source to any destination. Remember, there's an implicit deny all at the end. So the outcome of the option A is to deny ICMP traffic sourcing from wireless users and allowing all other ICMP traffic. All other traffic except ICMP are blocked. So it looks correct as it fulfills the requirement in the question. Let's go through the others. Option B. This ACL allows any traffic from any source to wireless users and block all traffic from wireless users. So question says allow only ping from wired host to the wireless users, but not all traffic. So this is not correct. Option C. First rule is allowing ICMP traffic from any source to any destination. Even wireless users can ping wired host. So it cannot fulfill the requirement given in the question. So it is not correct. Option D. First rule is denying ICMP traffic from any source to any destination. So it will not allow wired host to ping wireless users. So this is not correct. So the correct answer is option A. Okay, that concludes our training for today. I hope you found this overview of ACP Campus Access Exam topics helpful. We have discussed sample questions covering the areas such as wireless LAN, switching, routing, and security. Be sure to check out 591lab.com for more online courses, practice exams, and training materials to continue your certification preparation. You can also visit www.591search.com to learn more about our full suite of services. If you have any questions or concern, please don't hesitate to contact us. Thanks for joining today's class and I wish you the best of luck on your certification journey. Have a great day.